Today we're looking at definite integrals. Up until now we've thought of integration as undoing differentiation. We considered the fact that we need to use a constant of integration because we don't know exactly what function we came from. We looked at using differential equations to work out that constant of integration. And now we're moving on to applications that we use integration for. The one that we will be using it most commonly for is to find the area under a graph. When we're doing this, it's a definite integral because there's no plus c. We're going to be using values that we're given, which are an upper limit and a lower limit, to evaluate the integral at these points. So when we do a definite integral today, we will integrate as normal. We'll substitute in the upper limit, we'll substitute in the lower limit, and we'll subtract the two. And what we're left with will give us the value of this integration. And in the case of an area under the graph, it would give us the area that is under the graph. We'll look at graphs in a separate lesson. So the kind of integrations we're going to be seeing today are going to look like this. We've got our integral sign, we'll have an upper limit, we'll have a lower limit, we'll have the function that we have to integrate, and we'll be told what to integrate with respect to. Our first example is on page 7, and we're asked to integrate 5x squared with respect to x between the values of 3 and 1. So the first thing I'm going to do is I'm going to do the integration. I'm increasing the power by 1 and dividing by the new power. Now at this point I'm using square brackets because I've integrated but I haven't yet substituted. And on the square brackets I'm popping my upper and lower limit. Now I'm going to start to evaluate. I'm changing from square brackets to round brackets here. So first I'm going to substitute in the upper limit, so 5 times 3 cubed over 3, and I'm going to subtract the lower limit substituted, so it's 5 times 1 cubed divided by 3. Now a lot of these are non-calculator, so we're going to go through this non-calculator. Now I know the 3 cubed divided by 3 I could simplify, but I'm not going to because I know I'm going to end up with thirds in the second bracket, and so I'm going to have to do subtracting fractions, so I need a common denominator. So 3 cubed is 27, 5 times 27 is 135, 5 times 20 and 5 times 7. So I've got 135 thirds. Take away 5 thirds, which will leave me with 130 thirds. Now with this type of question, it's perfectly fine to leave that as a top-heavy fraction. You can change it to a mixed number. You wouldn't want to change it to a decimal. Next example is on page 7 as well. We're integrating x cubed plus 3x squared between the values of 2 and 0. So I'm going to head and do the integration. So x to the power of 4 over 4 plus, now this is going to be 3x cubed over 3, so the 3's are going to cancel out, so I'm going to go straight to x cubed. It's in square brackets because I've not evaluated yet. I don't need my plus c because it's a definite integral, not indefinite. And the values I'm going to substitute in are 2 and 0. So round brackets here, 2 to the power of 4 over 4 plus 2 cubed. Take away 0 to the power of 4 over 4 plus 0 cubed. 2 to the power of 4 is 16. 16 divided by 4 is 4. So that's 4 plus 8 in the first bracket. Take away nothing, which gives us an answer of 12. We have one more example on page 8. Okay, we're integrating 4 over x cubed between the values of 4 and negative 1. I can't integrate in that form. I'm going to use my index rules to bring that x up, and it'll be 4 minus x cubed dx. Now remember, I could move this 4 outside, do the calculations and multiply everything by 4. In this case, I'm just going to leave it there because it's not going to cause me any problems here. So 4 times x to the minus 3, when I integrate, increase the power by 1, so it's negative 2, divide by the new power. Between the values of 4 and minus 1. Now I'm not going to try to substitute in at the moment. Firstly, I'm going to simplify the 4 and the 2. So it's going to give me a 2 there and a 1 there. The x to the negative 2, I'm going to use my index rules to pop that underneath the fraction to make it positive. So this is now going to give me 2 over x squared, and the whole fraction is negative because I had a negative 2 on the bottom. Now I'm ready to substitute in. I don't want to see anyone trying to substitute into powers that are negative. So negative 2 over 4 squared, take away negative 2 over negative 1 squared. Do not try to evaluate on this line, we're only substituting. We'll start to evaluate now. So that's the same as negative 2 over 16, which is the same as negative 1/8. And I want to take away, be careful with your negatives here, I'm keeping round brackets so that I don't make a mistake with my negatives. I've got negative 2 over negative 1 squared, and negative 1 squared is just 1. So negative 2 divided by 1 is just negative 2. Which means what I actually have is negative 1/8 plus 2, and that's the same as 2 take away an eighth. There are 16/8 in 2, so if I take away one of them, I'll have 15/8 left. We will do a lot more work on this in class. We're going to spend 2 periods working on this. We'll just check basic understanding at this point. Do I need a plus c when I'm using definite integrals? And which limit do I substitute into the integrated function first? Is it the upper limit or the lower limit?